This video is to present an executive summary of the end-to-end automatic handling of small packages use case. The presented solution is developed in Trinity Demonstration Program 1, where one of the goals is to improve the agility of European SMEs in the manufacturing industry. This use case is presented by Trinity SME partner IT Robotics, located at the northeast of Italy. Beside IT Robotics, there's the Intelligent Autonomous System Laboratory of the University of Padua, and as application expert, there's Agile Vision. The growth of e-commerce is leading to the explosion of small parcel post shipments, and sector analysis indicates that 92% of shipments are small packages with a weight below 5 kilograms. However, profit margin for each managed package is constantly decreasing, and shipping companies have to balance between a low cost for their customers and the request of even faster shipment. In express courier hubs, weighing and sorting of small parcels are performed manually. Operators are subjected to stressful 3-4 hour shifts, in which they arrive to handle up to 300 packages per hour. The purpose of Trinity EACHPack is to automatize the handling and sorting of parcel posts that can be easily integrated in express carrier local hubs. The project has three main tasks. The parcels localization. Here, data coming from a 3D vision system are processed by an algorithm based on a state-of-art convolutional neural network to identify each parcel synthesis. Then, there's the grasp synthesis and motion planning module. It is in charge to identify a suitable grasping point for the parcels and to compute the robot trajectory to perform all the operations. In the end, the tracking module scans the parcel's barcode and weighs them to perform the sorting and the tracking operations. The vision system guides the robot to pick up the parcel. Then the robot places the parcel under the tracking system and deposits it over the scale for weighing. Operators can control the status of the system with a simple interface. In the end, the parcel is sorted with respect to its destination. The developed system is able to handle parcels both randomly placed and palletized. The developed system is able to correctly localize the parcel in over 99% of cases. Moreover, thanks to the sorting automatization, we have been able to reduce the sorting error by 85%. Currently, we reach a productivity of around 250 parcels hour. That is quite near to the human operator's one, even if our target is 400 parcels hour. The demonstrator brings three important contributions to agile manufacturing. First of all, the model-less object localization module allows to use robots in many sectors in which it is necessary to manipulate objects that don't have a fixed shapes or color, such as parcels, fruits, vegetables, and clothes. Then we have been able to reduce human errors. In the end, the system uses a data-driven approach, allowing even untrained operators to configure the system without the need to change dozens of parameters. The results of the project have different application scenarios. The main application is related to logistics and can be used in shipping carrier hubs, logistic companies, and warehouses to perform sorting, palletization, and depalletization. But it can also be tailored to work for the food industry to manipulate fruits and vegetables, or in e-commerce warehouses to handle products. Trinity support was fundamental to the project. They supported the project, but above all, they gave us many opportunities to network and disseminate our project and its results. This is a great help in finding new partners and customers interested in our experience. More details on the demonstrator are presented in the Trinity catalog that you can reach with the QR code on this slide. You can also contact us for more information about the project or use the QR code to watch other projects in the Trinity's YouTube channel.